Hello, stormwater designers. Welcome back to Clear Creek Solutions instructional videos. In this video, we will be going over another FE exam review problem. This one's going to be on Manning's equation. I am your instructor. A little bit about Clear Creek Solutions. We do software development, hydrology education, such as these videos, and conduct stormwater analysis and facility modeling for stormwater projects. Okay, let's get into today's problem. The problem states find the flow in a sewer pipe flowing full with a roughness of 0.012, a diameter of 2.5 feet, and a pipe that drops 5 feet over 100 feet of distance. And here's our answers: 35 CFS, 75 CFS, 50 CFS, and 100 CFS. And we're going to need to use Manning's equation to solve this problem. So it's first, we're going to read the problem all the way through, which we just did. Now we're going to identify what was given and what we need to find in this problem to solve it. So we're given n, the roughness coefficient, that was 0.012. We are given s indirectly. We'll have to do a quick calculation there to find the slope. We're also given a and p, which is p is the wetted perimeter, a is the area. We're going to need to find the slope indirectly, and q, which is the flow in the pipe. That's what we're given. We're going to want to use Manning's equation. This is the excerpt from the FE handbook. Q equals k over n, ar to the 2/3, s to the 1/2. It's important to keep our units in mind there. For this problem, it was in feet, so we're going to be using USCS unit. So 1.486 will be the K value, and let's see if we can fill in the rest of the values here. So use the information given to find slope, then plug that into Manning's equation to then find Q. So to find slope, it dropped 5 feet over 100 feet of distance, so the slope is going to be 5 over 100, or 0.05, which is usually measured in feet over feet. So that'll be the slope calculation. Pretty easy there. K will be 1.486 because this problem is in USCS units. So that's a couple of values right there. Now let's fill out Manning's equation. We have Q equals 1.486 over 0.012, which was the roughness, times A times R raised to 2/3 times the slope 0.015 raised to the 1/2. Now we need to find the area and the wetted perimeter. Now to find the area, we all know that the area of a circular region is pi d squared over 4. We were given the diameter, which was 2.5 feet. So we take pi, times that by 2.5 squared over 4, and we get an area of 4.91 feet squared. Now the hydraulic radius, this is a little trickier. It's also raised to the 2/3 power. So the hydraulic radius equals the area over the wetted perimeter. So not the entire perimeter, but just the amount that will be covered by the liquid. But since this pipe is full, it's just going to be A over P. So we have pi d squared over 4, which was the equation, over pi d, which is the equation for the perimeter of a circle. And after we do those calculations there, we get 0.63, and that's going to be raised to the 2/3 power in our final equation. So here's our final setup for Manning's equation to find Q. If we do the final calculations, we get Q equals 99.9 CFS in this particular pipe. And if we go back to the different options, 100 was by far the closest option. So we're going to select D as our answer. So the flow in this sewer pipe flowing full was 100 CFS. If you're confused about how to solve these problems and how to conduct, so just to recap, how did we solve this problem? We went back, we read the entire problem statement. We found out what was given, what we needed to find. We looked up the proper equations in the FE handbook, used what we were given to find some of the additional values, did some more calculations, plugged them into the final equation to find Q, and then we selected the closest answer. If you need a guide to helping you solve these water resources problems, there's quite a few different ones. This one's just on Manning's equation. We did a rational method one last time, and you're confused about the methodology or what step-by-step process you need, just click the link down below. We have the FE exam water resources guide. This breaks down the different problems you'll see on the FE exam and a method to solve them. Just click the link below, check out that guide, and you can download it for free. Other than that, I'll see you stormwater designers next time.